Welcome to your lesson on how to use Ohm's law. Now, Ohm is a guy's name. It's Mr. Ohm, Mr. George Ohm, and he was working on the relationships between current and voltage and resistance, and he found that there's a very simple mathematical relationship there. So here is what Ohm's law is. So Ohm's law takes the current. Remember that the current unit will be in amps, A for amps. And it just says if you want to know what the current is in a circuit, then you just need to have the voltage in volts, capital V. And if you divide that number by the resistance, which would be in ohms, then you'll be able to calculate what the actual current is. Or you can rearrange that relationship. As long as you have two of the three numbers that you need there, you should be able to calculate the missing piece. So let's just do a quick refresh on what current, voltage, and resistance is. So current is the amount of electrons flowing past a point in 1 second. So it's actually a rate or a speed. It's how fast those electrons are able to go through a conductor. The voltage is the pressure that's pushing those electrons forward. So that's how fast you can shove them through the conductor. And then the resistance is how much the material stops or slows or pushes back on those electrons to prevent them from moving. So in other words, voltage pushes forward, resistance pushes backwards. And it's the relationship between how much you can push forward and how much you can push backwards will decide how many electrons you can actually push through. Imagine that you and your friend are in a shoving match, friendly shoving match. You're pushing in one direction and your friend is pushing back on you. If your friend only pushes a little bit and you're pushing more, you're going to be able to push through. But if your friend is stronger than you, then you won't be able to push through, or you'll push through very, very slowly and not be able to have a very fast flow or current. Imagine that you have all these electrons piled up behind you trying to get through. If you don't push them through, they won't be able to get through. So voltage and resistance, depending on how much you push forward and how much you push backwards, will determine how many electrons can get through a particular part of a wire or part of a circuit in a particular amount of time. So the big equation that we need to use then is this one. So although A represents amps, when we're actually talking about the number, the actual mathematical value of the current, we actually use the letter I. So we say that I is equal to the V for voltage divided by the R for resistance. So this is our main equation. This is Ohm's law. If we want to rearrange the equation, let's say we wanted to have the value of V, then this R here would have to come up. You'd have to multiply both sides by R to move it to the other side of the equation and get V by itself. So that means that it would end up being V equals I times R. So that's the other version of it. Or maybe I want to get resistance by itself. In that case, I'd have the R come up and then the I would have to drop down. So R by itself would be equal to capital V over I. So those are the three different versions of the equation that we're going to need. Now let's get into solving some of these mathematical problems. So for each of these next few examples here, we're going to draw a circuit diagram, and then we're going to have to use the guess method of showing our calculations. And remember that the guess method means that you have the given with units, that's the GU, right? Given with units. Then you have the equation, then you have the substitution step and the solution. And I'll show you what that looks like. So let's give ourselves an example first. So let's say you have question number 1, and you were told that you have a 3-volt battery. We have a 3-volt battery. That's an important piece of information. So it's a 3-volt battery, and it sends a current of 0.10 amps through the light bulb. So I know there's a light bulb as well. Because I have to draw a circuit diagram, I also have to pay attention to the parts of the circuit here. And the question is, what is the resistance? So that's our question mark. So then we quickly draw our little diagram. So we've got a battery. We're not told how many cells it has. All we know is that it is a battery. So I'm just going to draw one cell to save myself some time. And it looks like the only thing that's on this circuit is a light bulb. So it's going to be a very quick diagram. All right. And then I want to put all my given information in. Now we're told, so we're going to do a given section. I'm told that it is a 3-volt battery. And this sounds like it's a little series circuit, so that means it's 3 volts everywhere. So I know that the V of the battery, or the V total that's given to the circuit, is equal to 3 volts. Then I know that the current is 0.10 amps. And I'm asked, what is the resistance? So there's an important piece of information, all those givens. And notice that I made sure I put the units in. I put volts and I put amps in there. Okay. My next step will be to choose the correct equation. And I can look up above there and I can see I know I'm solving for R. So clearly I need the R version of it. So R is equal to V over I. Then I have my substitution step. So I can say still don't know the value of R, but I know that the volts is 3 volts. And I know that the current is 0.10 amps. And then I just need to have my final answer. So 3 divided by 0.10 is 30. And I know that resistance is in ohms. So I can say, therefore, the resistance is 30 ohms. Okay, so here's where you're getting your marks from. Here is 1 mark. That's the GU given with units. Then you get your second mark here by having the equation. Then this is your third mark, which is the substitution step. That's just replacing the letters with the values that they represent. And then here you've got your final mark, and that is your solution with units. If it doesn't have the units, you can't get the mark for it. Because if you just said 30, it's like 30 what? So this is, the units is the important thing over here. Let me just actually put this as a full phrase. So given with units. So it's not hard to do well on this next assignment. You just have to be able to follow the format, and you should do very well on it. There's going to be 5 questions that are going to ask you to show your format, and then there'll be other questions that'll just be asking you to reason out and give me an answer. Let's look at a second example. Let's say you're being told that somebody is putting a resistor into a circuit, and you've got a battery in that circuit as well. So an 18 ohm resistor, which is just a little device you would insert into a circuit to slow the circuit down. And you're being asked, what is the current of the circuit? So we have good pieces of information here. We know it's an 18 ohm resistor. Gets placed in there with a 9-volt battery. And we're asked, what is the current? So there's our question mark. We have to draw our little diagram. So I'm going to say, okay, it's I don't know how many cells the battery is. I just know it's a 9 volts. So I'm just going to draw a single cell. And then I know it goes to a resistor. And the symbol for resistor is the one that has the mountains and the valleys. Mountain, valley, mountain, valley, mountain, back to level. Something like that. If I want, I can even write the given information right onto the picture as well, which is actually going to be useful for us later on when we're trying to solve some stuff. So I could say that I know that the resistance over here is 18 ohms, and I could say that the voltage of the battery is 9.0 volts. So I can write it right on my diagram if I want, or I do it as a separate section. So I can say the resistance is equal to 18 ohms, the voltage is equal to 9.0 volts, and the current is equal to my question mark. Then I go back up and I choose the right formula. So if you look over here, you can see that that is the correct formula already set up for us. So I is equal to V divided by R. So that's my second mark. Now I substitute in 9.0 volts divided by 18 ohms. And 9 divided by 18 gives us 0.5. And because it's in current, I know that the unit will be amps. Therefore, the current of the circuit is 0.5 amps. And likely that's why this person placed the resistor in there. If you didn't put the resistor in there, the current would be way too high. And it could, if you added another load in there at some point, then you may actually burn out the load. So you throw in a resistor to slow down the electricity, to help it either convert or just to prevent it from damaging another part of the circuit that might be more sensitive. So there you go. Current is 0.5 amps. So not too hard. And again, here's where the marks came from. You got a mark for the given section. You got a mark for the correct formula, a mark for substituting, and then another mark for having the final answer with units. You have to have units in all of this if you're going to get all your marks. Third example is a little bit more complicated, which is why drawing the circuit diagram helps you to figure out what's going on. So in this one, we have a series circuit, which is good information. It means I don't have any extra pathways to worry about. It's just one big loop, one pathway. So a series circuit with 2 lamps has a current of 2 amps. The first lamp has a resistance of 8 ohms. And the second lamp has a resistance of 12 ohms. So we've been given current, we've been given a couple of resistances. Obviously what the person wants is the voltage. So what is the voltage? But the thing is, what do you want the voltage of? Do you want it of lamp 1? Do you want it of lamp 2? Or do you want it of the battery? And in this particular case, we want the voltage that's being supplied by the battery. So again, the good information that we have is that it is a series circuit. That's going to help us draw our picture. We've got 2 of these lamps. Our current is 2.0. Because it's a series circuit, this should be the same everywhere. So we don't need lots of numbers for current because it is a series circuit. Then we know we've got 2 resistances, so we'll have to deal with them separately. And then we're being asked, there's our question mark, voltage of the battery. So let's draw out our picture first. So I know I've got myself a battery. Again, I don't know how many cells, so I'm just going to draw a single cell. And then I know it goes to 2 lamps. So I'm just going to use the light bulb symbol to represent that. So here's 1 lamp. And there's a second lamp. And now it would be wise for me to write on the diagram exactly what's going on here. So let's pretend that this is lamp number 1 and this is lamp number 2. I know that the current being supplied, the total current, is going to be equal to 2.0 amps. But because this is a series circuit, that means that the current that's going through this light bulb, So current number 1 is also 2 amps. And then the current of the number 2 of this light bulb is also 2 amps, again, because it's a series circuit. I'm being asked for the voltage of the battery. I don't know that yet. And I am told that the resistance of this first light bulb is 8 ohms, and the resistance of the second light bulb is 12 ohms. All important pieces of information. The thing is if I've got all this information about the light bulbs, but I don't have any voltage information about the light bulbs, how am I supposed to figure out what the voltage of the battery is? Well, if you remember, so that's a question mark. Voltage 2 is a question mark. If you remember the pattern of voltage for a series circuit, if the current is the same everywhere, then the voltage should be shared by all the loads. Then I know that if I can calculate this number here and this number here, I would just have to add them up to the total. So I know that the voltage of the battery, or VT, V total, is equal to V1 plus V2. And I know how to solve for V1. V1 is equal to the current of 1 times the resistance of 1. The current of 1 is 2.0 amps. Multiply that by the 8 ohms, and I get my voltage. So I know that the voltage is going to be 16 volts. Then I can calculate V2 using the given information for the second lamp. So the second current and the second resistance. The current's the same because it's a series, but the resistance of that second bulb is 12. So I put that in. And now I know that the voltage here is 2 times 12, which is 24 volts. I take that information over to my equation that gives me the total, and I say 16 volts, so I'm substituting in, plus the 24 volts. So that tells me that the voltage of the battery is equal to 40 volts. Therefore, the voltage of the battery is 40 volts. So that's your basic mathematical steps. There's one last thing that I want to talk to you guys about, and that is how to solve a circuit. So the rules that we just used there to help us, the idea that the current was the same everywhere and that the voltage adds up, are part of rules that help us to solve circuits. We have rules that help us for series, and we have rules that help us for parallel circuits. So let's look at just those rules now. So we're going to call this little section Solving Circuits. So solving series and parallel circuits. We're going to use Ohm's law and the 2 rules to help us solve for any missing information in a circuit. So rule number 1 deals with series circuits. So in a series circuit, and again, reminder that a series circuit just has the one pathway. So we're just going to draw a quick one with 3 little light bulbs. So in a series circuit, first rule is the current is the same everywhere. The actual flowing electrons only have one pathway. So it doesn't matter where you test in that pathway with an ammeter, you're going to see the current is the same. Let's make this light bulb number 1, number 2, and number 3. And then this would be the battery. So if we had the current flowing through that battery, we would say that the total current, which we now represent with I, so we would say that the total current through the battery is equal to, it's exactly the same as the current that flows through the first light bulb. It's also equal to the current that flows through the second light bulb, and it's equal to the current that flows through the third light bulb. And if we added another light bulb, it would, or anything else, anything in a series circuit, the current is the same everywhere. The second rule that we care about for series circuits to help us solve is that the voltage gets shared between the loads. So if the current is the same everywhere, the voltage gets shared. And those are the two principles we just used to solve that last question. Very important. In a parallel circuit, where we discuss rule number 2, you're going to see that both of those are flipped. But actually, let's just do our little mathematical equation here before we move on. We'll say that the voltage then, total voltage, that's provided by the battery, the push power of the battery, will be used up by a little bit by the first light bulb, a little bit get used by the second light bulb, and a little bit gets used by the third light bulb. So they share that total. It's spread out between the 3 of them. And again, if I added a 4th one, then it would be spread out between 4. So rule number 2. This one deals with parallel circuits. So for a parallel circuit, remember that we would have something like this, where we've got different branches for each light bulb. They got their own access, or their own pathways to the battery. There's light bulb number 1. We add another branch for light bulb number 2. And we add another branch for light bulb number 3. We'll number those guys, 1, 2, and 3. So what's the rule? Well, in this case, the current actually ends up being shared by each branch. Because as soon as it hits a division, it can decide to go to the one light bulb, or it can decide to continue past it, and the electron can go to a different light bulb. So the current gets shared. Current is shared. And then we would use the equation that the total current would be equal to whatever current goes through that first branch, plus all the electrons that went through the second branch, plus all the electrons that went through the third branch. So the current of each of those different branches. Then we can talk about the second part of the rule, which deals with the voltage. And this is that the voltage is the same everywhere. Or more specifically, it's the same in each branch. So then we would say then that the voltage of the battery, so the V total, voltage of the battery, is actually equal to any of the voltage in branch 1, it's equal to the voltage in branch 2, and it's equal to the voltage in branch 3. So the voltage in lights 1, 2, and 3 should be identical here, which you can see is the exact opposite if you're looking at those equations from what happened in the series circuits. So those are the rules. Now let's apply them to a couple of questions that'll help you be successful for your little assignment. Example number 1. So I'm going to show you an example of how to solve a series circuit. Okay, we're going to put quite a bit of information around the outside of the circuit, so please leave a gap between that title and the actual picture here. So here is the picture, and leave a gap on the side too. We're going to come up, we're going to draw ourselves a light bulb. We're going to have 3 light bulbs in this particular series circuit. So you know some of the information, but not all of it. You do not know the current of this light bulb. You do not know the voltage of this light bulb, but you're told that its resistance is equal to 1 ohm. Over here, you do not know the current of the second light bulb. So there's number 1, there's number 2, and there's number 3. Current, question mark. But you are told that the voltage over here, you've measured it, it's 9 volts. The resistance, however, is a mystery. You don't know the resistance. For the third light bulb, you don't know the current, you don't know the voltage, but you do know the resistance. And then you have tested the current of the battery. So you know that the battery is 4.5 amps. You don't know the voltage yet, and you don't know the total resistance yet. So you're going to be asked to fill in all of those blanks, right? What are all these missing pieces of information? So 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 missing pieces of information. Well, we're going to use those 2 rules above, plus our knowledge of how to use V equals IR, how to calculate, and we're going to just solve for those missing pieces. So step number 1. So step 1, I'm going to use Rule 1 to help solve for the current of each light bulb. Rule number 1. Well, what's rule number 1? Go back up. We look at rule number 1. We see that the current is the same everywhere. So if I know at least one of those current numbers, I know all of them. Well, that's nice and easy. So I come back to here and I look and I see, do I know any of the currents? Yes, I do. I know it's 4.5 there. So I know it's 4.5 amps here, 4.5 amps here, and it's 4.5 amps there. Beautiful. By the way, if you have multiple colors available, follow along with me and use similar colors, or at least have the numbers in the picture match whatever number you use for the step, because it's going to show you literally step by step how we ended up solving this, rather than it all just looking at one huge big piece of information at the end. Okay, step 2. We can't really solve anything else yet. We don't have enough information to tell us what the voltage is, and I haven't given you the rules for how to calculate resistance yet. We don't have enough information there, but we can use V equals IR, so we can use Ohm's law to solve for some missing info for each of these lights. So for using V equals IR, so how do we do that? Well, what's missing in the first light bulb? We're missing the voltage. We know the voltage is equal to the current times the resistance. I substitute that in, the current times 1 ohm, and I find out that the voltage is 4.5 volts. And I can go fill in my blank, 4.5 volts. Then I calculate the second one. Second one's missing the resistance. So the resistance is equal to, if you can't remember, you can always go back and take a look. The resistance formula is R equals V over I. So I'm going to use that now. R equals V2 over I2. I substitute in the values that I know. V2 was 9 volts over 4.5 amps. That means that the resistance there must be 2 ohms. So I've got that one. And then finally, I find the voltage for the third one. Again, that would be I3R3. I3 was 4.5, just like everybody else. R3 was 3 ohms. And I'm multiplying those together now, and I end up with 13.5 volts. Well, now I know all my voltages. Great, because I've got a rule up in rule number 1 dealing with series that helps me find the voltage of the battery. So I'm going to go back up, take a look at my rules. The rules for series says that the voltage is shared between the loads. Great. Vt is equal to V1 plus V2 plus V3. Awesome, because I have V1, I have V2, and I have V3. So my step then is to use rule 1. Solve for the missing Vt of the battery, and I know that Vt is equal to V1 plus V2 plus V3. And I look and I see V1 is 4.5, V2 is 9, and V3 is 13.5. And I just substitute those values in. Is equal to 4.5 plus 9 plus 13.5. And that tells me that the voltage of the battery is 27 volts. So I can go back and I can fill in the blank. It's 27 volts. There's only one piece of information missing now, and that's just that R value. I know how to calculate R. So step number 4, I'm going to use the V equals IR again, use Ohm's law again, to solve for that missing RT value. So then RT is equal to we have VT divided by IT, which is equal to 27 volts divided by 4.5 volts, and that's equal to 6 ohms. I can go back up and I can say that is 6 ohms. And now I have solved my entire circuit. Sometimes you use the rules first, sometimes you have to calculate first. It just depends what the easiest pathway is to get you all of that information. For your particular assignment, I don't need to see all of your work for this particular section. I just need you to fill in the blanks, but I'm just trying to reason out and show you how we can reasonably think about these particular types of questions. So that's an example of solving series circuits. Now let's work out an example together of how to solve a parallel circuit. How to solve a parallel circuit. So obviously now we're going to be using rule 2. Now we're going to make this quite a large diagram, because really wide diagram, because we're going to have a lot of information to put in. So we want to say, here's the battery. I'm going to give a ton of space before I make the branch, because I got lots to write in between there. I'm going to put a light bulb in. I'm going to give myself a nice size box so I can put the data in there. And do that again, because I'm going to have 3 light bulbs here. We know we're going to have I, V, and R for each of these, so we'll just quickly write that out. In this particular case, you don't know the current yet, so you have to figure that out for the battery. You are told, though, that the voltage that it supplies is 12 volts. It's a good piece of information. But you don't know what the resistance of the battery is yet. You've been given the current of the second light bulb. You don't know yet what the voltage is, and you don't know yet what the resistance is of that bulb. And then for this guy, you've got, I'm going to give you the current. The current over here will be 4 amps. I am not giving you the voltage yet. You have to figure that out. And I'm not going to give you the resistance. You have to figure that one out too. And then finally over here for our third light bulb, we've got the current. I'm going to give you that one. But again, I'm not going to give you the voltage here. And I'm not going to give you the resistance here. We have to reason those ones out. So we have little pieces of information that we can use here. Now, the first step is actually really super simple. I'm able to use the rules to help me solve for a whole bunch of information. So I'm going to use the rules right up front and minimize the number of calculations that I'm going to have to do. So let's go back up and we'll just take another look at the rules that we've got for parallel circuits. In a parallel circuit, the current gets shared. So if I have the current value of 1, 2, and 3 of all the loads, I can find the current of the battery, so that's good news. And then the voltage is the same in every branch. So if I have the voltage of the battery, or let's say I had voltage 3, I would easily be able to find out all the voltages as long as there's only one load per branch. So that should be pretty easy to do. So again, the current gets shared, the voltage is the same. So let's work that out there then. So I want to solve for IT there, and I use rule 1 to do it. So IT should be equal to current 1 plus the current in branch 2 plus the current in branch 3. And I've been given all of those values, so it's easy for me to calculate. So 2 plus 4 plus 6 gives me 12 amps. I can go and fill in that blank there. Great, that's done. I'm going to use the other rule to help me find all those voltages. I know that the voltage is the same everywhere in each branch. So we would say that the VT is equal to V1, which is equal to V2, which is equal to V3, that means they're all equal to 12 volts. So that must be 12, that must be 12, and that must be 12. That's awesome. I only have the resistances left, and the resistances are easy because I can just use the math to calculate them. So step 3, use V equals IR to calculate the resistance values. So it's all going to be the same equation over and over and over again. Nice and easy. So we'll have an equation there for the RT value, for the R1 value, voltage 1 over current 1. We'll have it for the second guy, and we'll have it for the third guy. All the totals, all the 1, 2, and 3. So if we go back up, we can see that it was for I and VT, it was 12 and 12, 12 amps and 12 volts. So there's 12 volts over 12 amps, which means that that is 1 ohm. Go back up and look for V1 and I1. It's 12 and 2. So it's 12 volts over 2 amps, which tells me that that's 12 divided by 2 is 6. Then the voltage and the current for 2 is 12 and 4. 12 volts, 4 amps. That gives me 3 ohms. And then finally 12 divided by 6. So 12 volts over 6 amps, which gives me 2 ohms. So 1, 6, 3, and 2. 1, 6, 3, and 2. And now I have completely solved for this particular circuit as well. So that's how we're going to use the rules and V equals IR to try to solve for these particular things. And again, sometimes you use the rules first, sometimes you use the calculations first. It really just depends on what information you have been given. That's the end of the note. Of course, like I did last time, I'm going to post that note for you, so you've got it to look at, or to print, or to copy for yourself.